Welcome to Climate Perspectives, a website that has been developed by the Southeast Regional Climate Center and the State Climate Office of North Carolina. This video provides a tutorial on how to navigate our website. Climate Perspectives provides a climate synopsis of recent temperature and precipitation patterns. It allows you to readily assess the extremeness of a recent or developing weather event or regime over the prior days, weeks, or months by seeing how it compares with the historical record during the same calendar period. You can investigate a single station or examine temperature and precipitation patterns across an entire region. So let's get started. You can develop three types of climate perspectives: a single station perspective, a regional map perspective, and a streaks and thresholds perspective. Let's develop a station perspective first. There are 5 simple steps to setting up a climate perspective for a single station. First, we identify the ending date of the time period in which we want to develop a perspective. We have a number of choices here. We can go back over the last 2 weeks, or we can go forward 3 days by utilizing National Weather Service forecast for the station of interest. Okay, the second and third steps are together, and these basically involve selecting a location. So we have 3 options here. The simplest option is simply to choose a predefined city. Second option is to key in an address and click Find, and when we do that, a list of stations will pop up in the box below. And the third option is to go over here to the Google map and select a region that we're interested in and double click, and when we do that, a list of stations will pop up. And so we basically select a station within here and click. Okay, and so that's step 3. Step 4 is to identify the most similar city by maximum temperature. And so we can choose either maximum temperature, minimum temperature, or precipitation. And I'll say a little bit more about that here in just a second, but right now we'll just stick with maximum temperature. Step 5 is the last step here, and we click the Update Climate Perspectives button. And so what we're presented with is a table that shows climate perspectives developed for various periods in the past. And so this starts off here in the first row with the very last day of the period, in this case here, July 26th. And so we've got information there, the maximum temperature, minimum temperature, average temperature, and total precipitation for that day. So for example, we can see here the high temperature at this location was 98 degrees. We see here that it was 9 degrees above normal. This is 9 degrees above the 30-year normals for maximum temperature for this particular day of the year. We also see that it was the 4th warmest on the record here. And this record, if we look up here, we can see that this record begins in 1944 and goes up to present. So it's a 69-year record. So this was a very warm day. It was the 4th warmest on record. And so we can look down through this table here and we can see for longer and longer time periods what time period really stands out the most. And so if we look at maximum temperature, we go down here, we see that over the past 2 days it was the 8th warmest, a tie for the 10th warmest for the past week. But going all the way down here to month to date, the average maximum temperature was 95 degrees, and that was the warmest on record, again over this 69-year period. And going back further, we can see that we see things really standing out going back over the last 6 months, where it's a tie for the warmest year to date for the past year and for the past 2 years. So this provides a great synopsis over a range of time periods, what really stands out the most. If we go over here to the last column, we have the geographical perspective. And so we have, based on maximum temperature for that particular climate period, what location exhibits a climate that's most similar. And so in terms of maximum temperature, it's very interesting. If we look down through here, over the past 3 months, we have San Juan, Puerto Rico. And so the temperature over the past 3 months, the average temperature is 87 degrees, almost 3.5 degrees above normal. that's most equivalent to San Juan, Puerto Rico. We also have the ability to examine the history for a selected climatological period. Let's take a look, for example, at month to date here. And so we see here, we click View History, we're presented with a table that presents each year in the past for this particular climatological period. So this would be July 1st through July 26th. And so we have an ability here to sort these years here, and it's by default it's sorted from warmest to coldest. And of course what we see here is for 2012, for this period, the average of 95.1, it ranks as number 1. And the second place here is 2011, ranked number 2, etc. We can sort this the other direction. We might be interested in this period to see what years were the coolest for this period. So we simply click this button here, and so then we get the sort going the other direction. And what we see is that the year 1979 was the coolest during this period, July 1st to July 26th. So it was ranked 69th. And so, of course, we can do this for the average low temperature, the average mean temperature, and also precipitation. Okay, and so if I click precipitation here, we can find that the driest year, ranking number 1, was 1966, with a little bit less than 1/2 of an inch. We can click it, sorting from heaviest to lightest, and we see that 1945 ranked as the wettest when they got nearly 8.5 inches of precipitation. Now let's move over to the right portion of the Climate Perspectives tool and take a look at the Streaks and Thresholds Perspective section. This is laid out very similarly to the Stations Perspective section, and so we're just going to keep things pretty much the same here. And one thing we want to pay attention to is step 4. We have the choice here working with high temperature, low temperature, total precipitation. In the example that I'm going to work through here, we're going to just stick with high temperature. Okay, so when we set this up here, we're presented both with period thresholds and streak thresholds. Now, a period's threshold indicates how frequently a given threshold has been reached or exceeded for each climatological period. So let's think about this here on the table, and let's just focus here on season to date. Okay, so we're going to look at the period June 1st through July 26th. And we can go down here and we can see that over the season to date, we've had 56 days in which the temperature is equal to or exceeded 60 degrees Fahrenheit. And we can see here we've got plus or minus 0. This means this is right at the 30-year climatological normals. It's tied for first. What's more interesting is to go down here and look at these period thresholds that are quite warm. And so if we go to the greater than or equal to 100 degrees Fahrenheit for season to date, we can see here at this location the temperature has equaled or exceeded 100 degrees Fahrenheit 9 occasions already during this season. And so we can see that this is plus 8.1. So this is 8.1 days more than what you would expect relative to the 30-year normal. So this is very unusual. And we can see here that this ranks first over the 69-year period of record. So let's go ahead now and we can click on this. Okay, so here we can see the daily period with maximum temperatures greater than or equal to 100 degrees Fahrenheit. And so these are automatically sorted from most frequent to least frequent. And we can see for this year that we're looking at, 2012, we can see that the 9 there, it's ranked number 1. And we can see right behind that is the prior year, 2011, and the year before that, 2010. So we can clearly see the last 3 summers, at least season to date here, are the warmest on record. We can also click this down arrow, and we click it, it sorts the other direction. So we can look at years in which there were no days up to this part of the season in which the temperature equaled or exceeded 100 degrees. And so we can scroll down through here and see that indeed there are quite a few days in which the temperature did not reach 100 degrees at this point in the season. Okay, let's move on now over to the second tab, streak thresholds. And so this is laid out, the table is laid out in a very similar way. But what we want to do is distinguish here what streak's threshold is. Streak's threshold specifies the longest streak in which a given threshold was equal or exceeded for each climatological period. So let's look at 100 degrees here again. And so we take a look at this here and we see that we have 6 days. And this will be 6 consecutive days in which the temperature equaled or exceeded 100 degrees Fahrenheit. And this is 5.4 days above the climatological normals. And we actually have the dates here in which this 5-day streak occurred, July 3rd through July 8th. And so clicking on this here, we can look and compare that with the past. Okay, so what we have here is a sorted list of the longest streaks for daily temperature maximums equaling or exceeding 100 degrees Fahrenheit. And so, as we just saw, this particular year ranked first in terms of the streak. And so we can look and see prior years that are right behind it. And so we see 2011, a streak of 5 days that occurred in which the temperature equaled or exceeded 100 degrees Fahrenheit. We can see here that it occurred July 20th to July 24th of 2011. And so just like before, we can scroll down through here and we can see, of course, that there are a lot of days in which there were no 100-degree temperatures observed. And so we have streaks there equaling 0 degrees. Let's move now to the middle portion of the Climate Perspectives tool, the Regional Map Perspectives page. When we click on the link, a map pops up revealing the pattern of maximum temperatures across the region on the day here. And so we can look at here and we can very readily see what the temperature patterns are across the region. And this particular day you can see it was an exceptionally hot day, and you can see where the reds and the oranges encompassing much of the area. Temperatures are very, very warm. Now we have a number of options here in terms of maps that we want to plot. We can choose to look at minimum temperature, mean temperature, and total precipitation. We can also choose between looking at average values, or we can choose thresholds. So for example, we might want to see the number of days for this particular month or this particular season that the temperatures equaled or exceeded a value. And we can also look at streaks. How frequently are streaks across different thresholds observed? We can also choose to look at different dates. Again, we can go and look for a few days into the future where we basically thread together a forecast with values that have been observed in the past. And we can, of course, start over the last 2 weeks, our time series. And then we can also look at the period here. We can look at the 1 day, past 2 days, all the way up to the past year and year to date. And then finally, we can choose for the station display whether we want to show the values, which is what we have here, the maximum temperatures. We can also show rankings, percentiles, or departures from normal. So let's move on and let's take a look here at rankings. Okay, so what we have here is a map that shows the rankings of maximum temperatures for this particular date right here. And so this was an exceptionally hot day across the southeastern U.S., and so this is reflected in the rankings that we see here. And so we see a lot of high rankings across the region, especially here from Alabama going up to Virginia. So we see a number of stations having a ranking of number 1. We see some variability across the stations, and some of this certainly relates to the station length. So some of the stations with the really long records, the rankings are not going to be as high. If you have any questions or comments, please don't hesitate to contact the Southeastern Regional Climate Center or the State Climate Office of North Carolina.